Hey guys, welcome back. As I teased in my previous video, today we'll be doing a case for the 5080 Noctua GPU. The GPU is massive as it uses triple A12 G2 fans to achieve silent cooling performance. The case I'm going to build for it is by far the biggest one I've done so far. Follow along as I show you how I built it. Like always, let's start with the plywood panels. Starting with plywood makes sense as it lets you test the layout and plywood is relatively cheap compared to solid wood mainframe. If any changes or mistakes happen, it would not be too costly to remake the panels. The sheer size of the Noctua GPU meant this will be the largest case I've built so far. The motherboard panel size far exceeds my laser cutter's working area, so I'll have to process it in stages. You can see here the panel is already sticking out past the work area. This simple window for the power supply is simply cut using a jigsaw. The motherboard tray consists of a 6mm base birch plywood and a decorative panel of 3mm Jara ply. The decorative panel will hide the mounting holes. Rear panel will also be made using multiple layers of plywood. These will first rip the width, then trim to length. Again, the sizes of these sheets exceeds my laser. Maybe it's time for an upgrade. What do you think? Forming the panel using multiple layers lets you introduce grooves without using a router. These grooves will support the motherboard tray later. Fitment of the panels were good, so I glued them together. Once dry, the edges are cleaned up on the table saw. Mounting hole locations were only lasered onto the top layer for ease of alignment. The remaining layers can now be drilled out. Decorative vent grille is glued in. I then trimmed the panels by 2mm each side to allow for edge banding. The banding is glued on, then excess planed off. The banding nicely hides the plywood layers and gives it a solid wood appearance. With the panels done, let's move on to the main frame. For this project, I got a really nice piece of Jara that's about 300mm wide and I think 1.5 meters long. It was from a really cool shop. I'll show you a short clip of that shop that I got it from out on the farm. But yeah, let's cut it up. We got the wood from this nice gentleman's wood shop. He said he used to order in truckloads of this particular hardwood as he used to build furniture. First, we square up an edge. Then, pieces cut to length. A thin strip is ripped off. This was used as the edge banding for the rear panel previously. Boards ripped to final width. I also used the table saw to chamfer the inner edges. Then bevel cuts for the joints. Grooves for the motherboard panel are done on the table saw along with one for the clear panel. I made sure to allow some clearance in the groove for easier installation later. Next, I marked out the cutouts needed on each panel. These were rough cut using drill and jigsaw. Large tooth blade is used for cuts along the grain and a fine tooth thin blade for the curves. The pendulum action should also be activated for cuts along the grain. And switched off for the curves. The rough cut was done 2mm smaller than final size. A template for the final shape was cut from the laser and stuck onto the board temporarily. A pattern following bit used to finalize the shape. The same method was followed for the bottom GPU vents. The negative scrap piece was used to cut the next template to reduce wastage. A large chamfer is also routed on the bottom of these vents for smoother intake airflow. The top panel is stuck onto the bench to route out the radiator cavity. As this cavity was a simple rectangle, pieces of scrap wood was used to form a template. Mounting points for the radiator are also added. A section was cut to mount the power button and USB ports. Finally, a rabbet is cut for the rear panel. The router is unstable due to the radiator cavity, so I filled it with scrap panels and shims to level it out. Hold position transferred to the panel. Threaded inserts added. Fitment of the pieces are checked before glue up. A slot was needed to allow the rear panel to slide in after assembly. Again, the scrap panels were used to fill the cavity before routing. To widen the slot slightly, paper shims were taped to the guide edge of the router. This will push the router slightly further away from the guide, creating a wider slot. 3mm acrylic was cut to fit. Parts were sanded before applying coats of clear varnish. While those were drying, I made some case feet as well. The push button was pressed in, followed by the birch cover. Perfect fit. The negative scrap cut from this area was used to cut the button face. I needed to rip the piece into 3mm stick, but it was unsafe to hold due to its size. So I glued it onto a larger piece of scrap to make the cut safely. Using the negative piece from this area will give an almost perfect grain match for the button. A bracket is printed to mount the 3 USB ports. Now for some finishing touches. 3 holes were drilled along the bottom for magnets. Mating magnets are pressed into printed coving that will guide the GPU air towards the rear fans. The coving was printed in 3 pieces to fit in the printer. Bamboo skewers were used for alignment during glue up. Similar method was used for the CPU rear cover. The eagle eye among you would have noticed that there are no fan mounting holes included in the motherboard tray. That's because I wanted to hide the screws from the inside and also allow usage of fan grills. So these spacers were designed and printed before gluing them directly onto the panel. Lastly, I tried using these slotted cable ducts to hide the cables. You'll see later that I should have gone with a bigger size. Okay, now we're ready for assembly. Okay, so if you've enjoyed the video so far, consider dropping a like and subscribing to my channel so you don't miss any future updates. With that, let's start on the assembly. Noctua fan grills inserted. I'll be using A14 and A12 G2s for this build. ASUS TUF B860M. Fan cables routed through the duct. Again, I'll be using the Ultra 7 265KF. Motherboard panel slides in. Followed by the rear panel. STRIX 1200 watt platinum PSU to power this PC. Printed mounting plate. Here is where I realized the cable ducts were too small to hide all the cables. I used 25 by 30mm ducts. In future, I would try 25 by 50 ducts, which should be enough. The 24-pin ATX cables could not fit into these ducts. Moving on. The CPU will be cooled by an ROG RYUJIN 3 AIO, but we will be using the Noctua A12 G2s instead. The provided screws were longer than standard, so spacers were needed. Radiator is positioned, then secured with the 4 brackets. To decorate the top of the radiator, 2 slats were cut from remaining plywood and glued onto a bracket. CPU cooler backplate was installed. Followed by securing the block. 64GB of DDR5 goes in. PCIe extension installed, then the custom front and back GPU brackets. Now, the beast Noctua 5080 can be installed. This is by far the biggest GPU I've seen with triple 120mm fans. Mating brackets installed for the front and back. These allow the GPU to be seated into the case, giving a stress-free installation. 4 screws further clamp the brackets together. The coving and divider we made will direct the hot GPU air towards the rear exhaust fans. With that, the case build is complete. Time for some testing. During full load, the CPU sits around 70 and the GPU at 64. The fan speeds are displayed on the screen. The PC emits a light hum which is very tolerable. Out of curiosity, I tested the PC without the side panel and saw a reduction of about 5 degrees on both components. What do you think? Do you like the design of the case and the new Noctua GPU? Let me know down below. I will admit I spent less time on this Noctua build compared to my previous Noctua build, as I just went on vacation and had less time to meet the deadline. But I do think the final build is still a nice, simple design that stands out from the rest. As always, thanks for watching till the end, and I'll see you in the next one.